Okay, so we're recording this now. Another method that is quite popular with the on the capstone class, and this is going to talk about inventory costs, and especially anyone who is going to work with or in their capstone project work with supply chain management. So this is really going to focus then on supply chain management. When you're working with supply chain management, there are basically two big costs that are involved. Number one, the ordering cost or the procurement cost, and number two, the carrying costs or the warehousing costs. So you've probably worked at companies where they have a procurement department. The primary purpose of the procurement department is to buy goods and services for your company. Or you may work for a company that just has huge warehouses, that have huge warehouses. So the procurement costs and the warehousing costs, those are expensive. Those are expensive. So what is our objective then from the finance and accounting portion? To minimize those costs as much as possible, to minimize the procurement costs, and to minimize the warehousing costs as much as possible. We know that those costs are going to be significant. Therefore, let's go out there and try to minimize those as much as possible. Here's a little bit finer breakdown of the inventory costs. You're going to have your ordering costs, carrying costs, capital costs, storage space costs. Those are mostly the warehousing costs, inventory service costs, and inventory risk costs. And inventory risk cost basically is the cost or the probability of a stock out. In other words, you need the inventory, but for some reason, the inventory is not there. Bad, bad. So you want to make sure that you have enough inventory, because if you don't, what happens in many cases is that your production line gets stopped because they don't have the product. Okay, so we want to introduce then what's called the economic order quantity. And the economic order quantity, what this is it's going to be a form that tells you every time you place a cost, I'm sorry, every time you place an order, how many items should you order? Every time you place an order, how many items should you order? So that's going to say for this inventory item, every time you place an order, you can order any amount, but the economic order quantity says, yeah, every time you place an order for this particular item, you should order 20,000 to minimize the associated inventory costs. All right, so here's the formula then for the economic order quantity. Here's the formula then for the economic order quantity. You can see where I'm circling there. And the economic order quantity then is equal to the square root of 2 times the annual demand or annual consumption times the ordering cost per order, all of that divided by the carrying cost or the warehousing cost per unit. Okay, so it's ordering cost per order divided by the carrying cost per unit. Ordering cost per order divided by the carrying cost per unit. What did I do? Okay? So in this case, remember, it's ordering cost per order divided by the carrying cost per unit. The carrying cost per unit. Okay, so the economic order quantity is a technique of inventory control which goes out there and minimizes the total inventory cost, and again, inventory cost being the cost of procurement and the cost of warehousing. So the procurement cost and the warehousing cost. We want to minimize that combination as much as possible. We want to minimize that as much as possible. Okay? So that's what the economic order quantity is going to do. It's an accounting formula that determines at which combination of ordering costs and warehousing costs are the least. The result is the most cost-effective solution. In purchasing, this is called the order quantity, and in manufacturing, this is called production lot size. So from your operations management course, you have the order quantity from purchasing and what the production lot size is. You're going out there and making batches. How many in the batch should you go out there and produce? Okay, so again, what is the economic order quantity? It's the quantity of the inventory and material which can be purchased at minimum cost. Okay. It is the size of the lot to be purchased which is economically viable, which means that it works and you're going to minimize costs at the same time. It works and you're going to minimize costs at the same time. So you'll see it referred to also as the Wilson formula, okay, because I guess that's the guy who went out there and did this. There's the formula there, okay? The economic order quantity is equal to 2 times annual demand. S is the ordering cost per order. How much does it cost to place an order? All of that divided by the carrying cost or the warehousing cost per unit. Warehousing cost per unit. So S, every time you place an order, how much does that cost? Okay, that's basically all the costs of procurement. And H is for this one item, how much does it cost to warehouse this one item? So if we were going to put the warehousing costs and the ordering costs on a graph, on a graph, what does it look like? What does it look like? Okay, so here then, here's the cost, and here's the order quantity. Here's the order quantity. So you see here, first off, this light green line is the order quantity. So it starts off high and then goes low. The order quantity is on the horizontal axis. And what does that mean? What does that mean? If you place small orders, you're only ordering 2 or 3 at a time, then that means that you're going to have to place a lot of orders, and all your ordering costs are going to add up because you're ordering too small of a quantity. Versus out here, again, looking at the ordering cost, let's say that you're only going to make 1 order per year, but that order is a big order. You need 100,000 per year. How many are you going to order? 100,000. You're going to order it all at one time. Your ordering costs are going to be very low because you're only placing 1 order. On the other hand, your inventory costs, which is this darker green line here, the warehousing costs, you place 1 order at the beginning of the year, your ordering costs are going to be low, but you're going to have to do a lot of warehousing. You're going to have to do a lot of warehousing to handle all of that inventory. So your ordering cost, you make 1 big order at the beginning of the year. Your ordering costs are low, your warehousing costs are high. Versus if you're going to make a lot of little orders throughout the year, real small orders, your ordering costs are going to be very high because you're making all of those orders while your warehousing costs are going to be low. Your warehousing costs are going to be low because there's not much to warehouse. All of it, everything that you need is available almost immediately. So your warehousing costs are going to be low. But your ordering costs are going to be high because you're placing so many orders. The total of your warehousing costs and your procurement or ordering costs, the dark green line plus the light green line gives you this olive colored line. Okay? This is your total inventory cost, the cost of procurement, and the cost of warehousing. Where do you want to be, obviously? At the low point of the olive line. Where is this low point going to occur? You can see here where the warehousing costs and the ordering costs, where they cross. Where is the low point of your inventory costs going to be? Where your ordering costs and your warehousing costs, where they cross. Okay, so again, what is the economic order quantity? It's an inventory management system based off a simple formula that's used to determine the best number of items to order. It's going to tell you to order 10,000 items. It's going to tell you to order 400 items. That's what the economic order quantity is. So that you consistently order. Let's say that we come up with a number of 400. you consistently order 400, you're going to minimize the warehousing costs and the ordering costs. All right, so what are some of the key assumptions? The constant per unit warehousing costs. Every time you place an order, that's going to be the same. Your usage of inventory is pretty standard, no quantity discounts, and lead times are always the same. They won't change. The lead times are always the same. They won't change. Okay? And again, here we are with some of the assumptions of the economic order quantity. All right? Now, in real life, you know how big supply chain management is. How big supply chain management is. You probably know, on the 15 freeway south of, I think between the 91 and the 10 freeway, is there like a big Amazon warehouse there? I mean, really big Amazon warehouse. I think so. I think so. Okay. And so, but in real life, this inventory management that we're looking at here, 80% of the companies don't use it to its full maximum. 80% of companies don't use it to its maximum. All right? Which is a shame because they're losing a lot of money. They're losing a lot of money. So it's not like this stuff is new, but companies don't use it because it's complicated. All right? So here's an example of an EOQ calculation. So we have here the annual usage for this item is 2,000 items, 2,000 units. Every time we place an order, how much does it cost? $50. We have basically the carrying rate is 25% of the item cost. So in this case, 25% of 8, the cost of warehousing this item, 25% of 8 is 2. The cost of warehousing this item is $2 per unit per year. The economic order quantity, 316. What is that? 316 units. 316 units. Every time you place an order for this item, you should order 316 units. Based off this annual demand of 2,000, the ordering cost of 50, and the warehousing cost per unit of 2, every time you place an order, you should order 316 units. That's what the economic order quantity is telling you. Okay. Same calculation, same example here. Again, it's the same thing. It's called the Wilson. So the annual demand is 3,000 units in this example. 2 times 3,000. This 2 is how much it costs to place an order every time you place an order. $2. The warehousing cost per unit is equal to 3% times 20, 60 cents. So 6,000 times 2 divided by 0.6, take the square root of that number. Okay. Every time you place an order, how many items should you go out there and order in this case, based off these parameters? Okay, 141. 141 units. Every time you place an order, you should order 141 units. Any questions? Any questions? Okay, and again, as I had said earlier, for those people in their capstone, when their capstone involved supply chain management, many of them used these formulas, and that was good enough. They didn't have to do the master budget because they were doing this financial analysis, and that was good enough for the capstone. Okay, so any questions? Any questions? All right, so we have the other formulas here. Do I need any formulas down here? No? All right, so let's do an example. Make this bigger. Okay, so let's say then that the annual demand for this item, I'm just making up all these numbers now. So the annual demand, let's say that this is 20,000 units. The ordering cost per order, every time you place an order, let's say that that's going to be equal to $200 per order. I'm just making this up. Okay, and the warehousing cost or the carrying cost per unit, and let's just say that's $5 per unit. Okay, I'm just making up all these numbers. I'm just making up all these numbers. Okay, now, these numbers I'm not making up. These numbers are all calculations. So let's put a space here. The economic order quantity, every time we place an order, how many should we order? Okay, so let me do the square root a second. But this is going to be equal to, in the numerator, 2 times the annual demand times the ordering cost per order. All of this divided by the carrying cost per unit. Okay, and let me take the square root of that number. I take the square root of all of this. Hit enter. Okay, so I come up with this funny number here. But every time, and let's just round it up, every time I place an order, I'm going to order 1,265 units. Got to round it up because it can't be a decimal point, right? 1,265 units. Okay, so how many orders per year am I going to make? How many orders per year am I going to make? If every time I'm ordering this amount, 1,265, how many orders per year am I going to make? This is going to be equal to 20,000 divided by 1265. 20,000 divided by 1265. So I'm going to place about 16 orders per year. Okay? What is my, on average, how much inventory am I going to have? That's just going to be equal to the economic order quantity divided by 2. So on average, we're going to have about 633 items, 632, 633 items in the warehouse at any one time. All right. How many, what is going to be our total ordering cost? What is going to be our total ordering cost? We're going to place 15.8 units of orders per year times 200 per year, 200 per order, I'm sorry, times 15.8 per year. My total ordering cost is going to be equal $3162.278. 3162.278. Any questions? Everyone see how we get those numbers? All right. My total carrying costs, on average, we're going to have 632. The warehousing cost per unit is equal to 5. So this is going to be equal to 632 times 5, 3162.278. Okay? So you look at these two numbers are the same. These two numbers are the same. Does that make you nervous? Does that make you nervous? No, right? Because remember, where do we want to be on the chart? At the point where the ordering costs, the light colored green, and the warehousing costs cross, are equal to each other. That's going to give you at the bottom of the curve. So if they're equal to each other, like we see here, then we see, okay, we've done this correctly. So our total inventory cost, and this doesn't include, and how about let me put it this way, the total inventory overhead cost, uh, 6324.555. 6324.555. Okay, and then finally, days between orders. So we're going to place about 16 orders per year. So I'm going to do days between orders. That's going to be equal to 365 days a year divided by this 15.8, about 23 days, which means what? Which means what? Every 23 days, you're going to place an order for this item. Every 23 days, you're going to place an order for this item. Okay, so probably what you're going to do is that you're going to computerize that so that it's going to place an order for you every 23 days for this item. All right, so you look at this, and as long as you have these inputs are hard to get. But as long as you have these inputs, that's not that hard to do, right? But what's the problem? This is only for one item. This is only for one item. How many items, like if you look at your local Walmart, how many items are in that Walmart? You have to do this for every single item. You have to do this for every single item. And as these things change, you're going to have to redo these calculations. Okay, so I did something like this. It's a never-ending battle. It's a never-ending battle. I can't tell you how many times I wanted to jump out the window because of all the calculations that are necessary. It is just a killer. It is just a killer. Okay, it's a lot of work. It's a lot of work. But in real life, a very effective management system. All right, so let me stop recording.